Yeah, hello.
Okay,
Yes, yes.
so this is where you got to. Uh-huh. So from here, what you are going to do is to establish a relationship between the row one and row two. Do you get it? So we're able to establish for row one. The row one, we said it should be equal to the 2p over what? Um, it was pi
I
squared
squared EI theta L
EI
EI
theta,
over L squared.
EI over L squared. Very good. Let's establish for 2. So P2 is equal to, that load was 3p. Do you get it?
Yeah.
All over pi squared. The I was 2i. Do you remember? And the L was 1.5.
Please, your voice is down, eh?
The voice is down. Can you hear me?
Okay, yeah, I can hear now. Yes.
Okay. So here was 1.5. The length was 1.5. That's squared. It was 1.5 L. So 1.5 L squared. Do you get it?
Yeah.
Uh-huh. So we have to make this denominator look like what we have here. Please, you get what I'm saying?
Yeah.
Okay. So here it's going to be like we have 2i over what? 1.5 squared is going to be, I think, 2.25 or something. Or
3.2. Yeah.
1.5 squared, 2.25. Or
Yeah,
did you get that?
2.25. Yes. Yes.
2.25. And 2.25 is just like 9 over 4. But let's take it 2.25. So 2.25. 2.25.
Yeah.
Okay. So 2 over 2.25 is what?
Is that what?
2 over 2.25.
0.89.
It's like 8 over 9.
Yes.
So here
Zero
is,
point 0.89.
okay. Okay. So it's like 8 over 9. So we have like 8 over 9 here. Below here, we have, this is like multiplying 8 over 9. So what we can do is that we can send this upwards here. And it will turn to 9 over 8. Do you get it? This one.
Okay.
This is at the
Hello.
denominator side. Do you get it?
Hello.
You get it?
No.
The 8 over 9 is like at the denominator side.
Okay.
We don't have this anymore.
Okay.
We don't have this anymore. So this is what we have. L squared with a multiplying factor of 8 over 9. So this can go, the 9 can come up and it will be over 8. Did you get it? So that
Yeah.
this will go off. So right now, what are we having?
Now I'll be now I'll be multiplying the 3p.
Yeah, yeah. So it will be like 27 over 8. Is that correct?
Yes.
Multiplying p. Have you seen it?
Yes.
Mhm. So let's compare this with that. So it's like P1 will be how many times P2? Or P2 will be how many times P1? 27/8 is what? Can you give me the value?
Is that what?
27/8.
3.375.
3.375.
375.
Okay. So 3.375. You are comparing 2 to 3.375. So you just have to divide here by 2. Do you get it? And it will be like you've divided, this is P2. And this is the down one is P1. Is that correct? Please, you see what I'm trying to establish a relationship between P2 and P1. And I'm using their coefficients. The coefficient here is what? 27/8.
27/8.
That's for row 2. And for row 1, the coefficient is what? 2. So
2.
I chose to divide the row 2 over row 1. That's row 2 over row 1. Please, have you seen it?
Yes, sir.
So row 2 over row 1, what are we having? Row 2 will be what? It will be some multiplying factor of row 1.
1.6875.
1.6875
6875.
times row 1. Please, do you get it?
Yes, sir.
So it means that our first R value, that for maybe R1, the first value that you do, that will be for R1. And when we multiply that by this factor, and when we multiply the corresponding P1 by this factor, we should get
Your voice is going.
Hello.
Yeah.
I said that
Yeah.
the first value of R1 that you assume,
Mm.
do you get it? The
Yeah.
first value of R1 you assume.
Yeah.
The corresponding P1 will be multiplied by this factor to get P2.
Okay.
And the P2 value will give us the corresponding R2 value.
Okay.
Please, you get what I'm saying?
Yeah.
So we are done with this side. We have to go to the table and check. But it's a try and error method. So you first have to assume a value. The equation is here. And also, don't forget, on the table you have R1 and you have C. Let me open the table and share. But keep the value. It's what?
1.6875.
1.6875 times the P1. Okay. Can you see what I'm sharing?
Yes, sir.
Okay.
Yeah.
So what's happening? You first have to assume a value of R1. Do you get it? So let's assume a value of 2 point something for R1. And don't forget, RC is also here. RC squared is here. Have you seen it?
Yeah.
So we really don't have a lot of problem. So we just have to know our R1. So R1, let's go to 2 point something and start from there. So let's start from here. So if our R1 is 2.4674, our corresponding p-value is what? 1. Is that not it?
Yeah.
So that's P1. And P1, we multiply it by what factor? 1.68. So note the numbers now. R1 is what? 2.4674. And the P1 is what? 1.0. Is that not it? Row 1, row 1 is 1.0. So row 2 is what? 1.6875 times 1, which is the same as 1.6875. Please, have you seen it? So we have to look for 1.68 here. 1.6875. It's just like 1.69. But you have 1.68 here. We have 1.70 here. So what are we doing? If you want 1.69, you have to do interpolation. Is that not it?
Yeah.
Uh-huh. So here is it. So let's do some interpolation for it. So what are we having? What are we having? Sharp, sharp, sharp. Come. So 1.68 and 1.70. 1.68 is 1.0282. And this is 0.9779.
9779.
Then you press AC, then shift start. Then you go to regression 5. Then you press 5 again. Then in front of it, you put the actual value you want its correspondent, which is 1.6875. So what are we having? So we are having a value of 1.0093375. Have you seen it?
Yes, sir.
Okay. So from that side, RC squared is going to be what? I think there's the RC squared. RC squared is going to be what? 9.5864. No, we have that one. We have to interpolate between this and that. Please, have you seen it?
Yeah.
So let's do another interpolation for that. So start. See. So 1.68. What it was R1C. Was it R1C squared?
Yes, R1C square.
So we don't have to follow R2. Do you get it?
Yeah.
You have to follow R1. R1 was what? 2.46 something, right?
The R1 is 2.4674.
So A squared is this. The corresponding R1C squared is this. Do you get it?
Okay.
So we just take it straight. So let's put them in the equation and see whether you will get a balanced something. I hope you still have the equation.
Yeah.
The equation was 3 plus
3 plus R1.
3 plus R1
R1 plus 3
multiplying R1
plus 3 plus 3 on 4 R2.
It was 3 on 4 or 4 on
Yes.
3.
R1 plus 3, 3 on 4.
It's what on 4?
R1, yeah, plus, yeah, 3 on 4, 3 over 4,
Really?
R2. Yes.
No, I think it's 4 over 3.
4 on 3, 4 on 3.
Uh-huh. 4 over 3.
Yes, R2.
R2. And the whole of this should be equal to R1 C squared, right?
Yes.
Okay, so let's put them in the equation. You know your R1 is what 2.4 2.4674.
674.
And R2 was, what did we find for R2? 6. It's what 6. Hey, please, what did you get for R2?
R2,
The one we interpolated. What answer did we get?
we got, the answer, I did not do it myself, but what we got was something 1.00
Yeah, 1.000 something.
something.
Or you want us to do it again?
And let's do it again so that
1.68. It was here that we were interpolating.
okay.
So it was 1.68 and the correspondence was what? 1.02
1.7.
0282, right?
Yes.
Then here was 1.7. And the corresponding value is what? 0.9.
0.9779.
Okay. So shift that regression is 5 again. Then you put a value of, you wanted 1.68
Yes.
6875.
Yes.
Okay, so this is the value we are having for R2.
1.00.
1.0093375. Is that correct?
Yes.
1.6. 1.00. So put them in the equation.
93375. 75.
Yeah. Hey,
Yeah, 3
3.
is 2. Yes.
Okay. So there's it. So let's start punching them. 3 plus R1 is what?
R1
2.4674.
is, yes, 24674.
multiplying 3 plus another 2.4674 plus what? 4 on 3
Plus 3 first. Before plus 4 and 3.
plus 3 again. I've done the plus 3. Oh.
Okay, yeah, that's it.
4/3
And R2.
times R2. R2 is what?
1.0093375.
Oh, this is the value we are
That is
having.
7 point. That's 7 point something.
It's what? 37.25.
0.2503.
Wow, that's a really a big value. And R1C1 was
Why is the R1C square? What is the value of it?
it was here. It is here. 6.0881.
Yeah. It's very big.
It's very big. The value is very big. I'm trying to check the value that they used. Let me see it. Can you see what I'm showing?
Yeah.
Oh, they even were doing try and error.
Okay.
So the real answer is, what is this? They had R1 to be negative 3.5159. That's where they started from.
Okay. That's why they started from.
They did negative then. Yes. You see,
Okay.
when they tried the first one and it didn't pass, they tried another one when R1 is negative 3.5159.
Yeah.
So I think we can also, if there is time there, I'm tired.
Yeah.
So they tried negative 3 point something. So, but that's how we do it. So negative
Yeah.
something like
So
this.
now,
Something like this. Then this is the corresponding P1. So you multiply by your
yeah.
factor to
Okay.
get your corresponding P2. Then you go and check that one. It's corresponding R2. Do you get it?
Yeah.
But you will maintain this will be your RC squared.
Okay.
Yeah. So you do it like that.
That's the 6 point. We maintain that 6.
No, you will maintain that 6.
Will not maintain it.
When you change your R1, that R1C squared 2 will change.
Yeah, it will correspond to different rule. Then yes.
Yes.
So it will change the R1 RC
R1C
square.
squared. Yes. Do you get it?
Yes. Yes.
So you do it like that until it passes or it gets closer to the value.
I think now the understanding have been gotten.
Yes. So after getting when it gets closer to it, it means that the corresponding row values that you choose, that's what you are going to equate to the one you set up, the equations you set
Yeah.
up for the rows.
Yeah.
Then you calculate for the p's and you take the smaller p. You get it?
Okay.
That's
Okay.
it. You are done.
Sure.
Then also if you can revise what do you call it? The composite. I'm tired. I don't think we can do the composite again.
Maybe if you can just brush through like reading kind of thing.
They
Yeah,
are
but not
formula.
detailed.
They are formula works. You get it. So
Okay.
I think if I send you the form, if I send you the notes, you can read it and get to the understanding.
Okay.
You have to. You first have to know the equation when the first condition. Equation you use when is the second condition. So mostly we check for moment capacity.
Okay.
Moment capacity.
Okay.
Yes. And before you can check for the moment capacity, there are 3 different equations that you need to know.
Okay.
The equations are there, but let me check if I can share the equations.
Okay.
Um, so for this question like this, I don't know whether you can, let me clear. Let me clear this. So can you see the question? It says what? You should check the moment capacity and check the shear capacity.
Yeah.
So there's still section 356 by this is the section. So you have to go to, I don't know, maybe he will provide us with the characteristics. You have to know the characteristics of this section.
Of the session, yeah.
You get it? The characteristics are, I mean, the web width and then the flange, whatever.
Yeah.
Those ones. You have to know them.
Yeah.
Then he has given you some imposed loads and some weight and partitions and things. You are going to do the calculation for, you are going to check moment capacity. And before you can check the moment capacity, you need the loads on it. So let me see how the person did it. So you can see finishes is here. You know, this is the general equation for your loadings. 1.4 times the dead load, 1.6 times the live load.
Yeah.
Okay, so the finishes and the other things will go to the dead load side. So finishes is 1.2 kilonewton per meter squared. But first, you have to know the area that will contribute to that beam or to that beam. You get it? So this is
Okay.
the area that will contribute. So you first have to find that area. The area of this is 3.5 times 9. Have you seen it?
Yeah.
So 3.5 times 9 is the area. Then you multiply by the finish, the value that it was given.
Okay.
So 1.2 times 3.5 by 9. Then you get the load.
Yeah.
Then for the service load too, you do same. You get the load is self weight. The self weight, you know, the thickness is 0.15
Yeah.
by what do you call it? The area. The area is
Yeah.
this 3.5
Yeah.
by the 9. Then you multiply by the
Yeah.
unit weight of concrete, 24. You
24.
get this, yes. Then the self weight of the beam. The self weight of the beam itself.
The section times.
That's the section. The use of 45 I'm coming. Let me check. Okay. So you know that whenever a few section is given, the last part represents the weight in kilogram per meter length.
Mm.
Do you get it?
Okay.
The 45 is in kilogram per meter.
Okay.
Okay, so if you want to change this to you want to calculate the load from it, it means that you have to multiply by, it's in kilograms. So if you want to change it to newtons, you have to multiply by what? 9.8
Okay.
to convert it to weight. Do you get it?
Okay.
And the weight is per meter, but we have 9 meters. Do you get it?
Yeah.
So times 9. And you are converting it to kilo. So you have to divide it by 1,000.
Okay.
That's why we are having this value.
Okay.
After that, you come and do your combination of dead load and live load. So the live load consists of what? The finishes, the self weight, and then the service loads. Do you get it? So all these
Yeah.
ones are dead loads. Please, you get it?
I get it.
So you sum everything
Of
and you factor it by 1.4. Please, you get it?
Yes. As the
Then,
dead load.
yes, he gave you an imposed load. The imposed load was, it was given in the question. Where is it? Imposed load of, have you seen it? If the imposed load, can you see that? Check the main
Yeah.
question. If the imposed load is what? 4 kilonewton per
Um.
meter squared. Have you seen it? And the partitioning too
Yes.
is
1 kilonewton per.
1 kilonewton per meter squared. So you sum the two. That will give you the live load on it. But I was thinking the partitions will be added to. I don't know why they added. Do you get what? Please, you get it? I can't hear you. Okay, so we assume we've calculated for the live load too. Then you put them and factor all of them, the two. Whatever you get it in kilonewtons because you converted it all to kilonewtons. Yes. Is there any question? Is there any question? Okay. So after that,
Yes.
we wanted to have it in what do you call it? We wanted to have it in UDL. So after everything, we multiply by we divide by the 9, which is the length of the beam, to spread the load on the beam. Do you get it?
Yes.
So we spread the load on the beam like that. Then what we do is we calculate the moment, the MA. You know, omega L squared over 8. But here we could have maintained the answer we got from the N.